Hello students, in this video I will explain the conversion of NDFSM to DFSM using subset construction method. The steps in the conversion of a NDFSM to a DFSM is as follows. First we identify the start state of the DFSM, followed by identifying the alphabets of the DFSM. Then we identify the states QD of the DFSM, identify the final states FD of the DFSM, and then we can identify the transitions delta D of the DFSM. So let us take an example to understand the conversion of NDFSM to DFSM. Consider the question as, let L be a language that starts with letter A over a set of alphabets sigma equal to A, B. Convert the NDFSM to DFSM by subset construction method. Now the solution to this problem goes like this. The language, I'll consider L is equal to a language which starts with letter A. And the input alphabets are A, B. Therefore, if we are constructing an NFSM, it tells us that always the strings of the language should start with letter A. So this first character is fixed in the language, and then it can have any number of A's and B's. So when designing the NFSM, we have got the start state Q0. On Q0, when we give an input A, it goes to Q1 state, and Q1 state is our final state because we finish reading this input, and after that we can have any number of A's and B's. Therefore, in Q1 state we can give any number of A's and B's. Therefore, Mn, that is our NDFSM, is defined as Qn sigma delta n Q0 as the start state and Fn. So if we were to explain this, then we have two states, Q0 and Q1. Alphabet is A, B. Delta n will list them out. Q0 is the start state and Q1 is the final state. So the transitions go like this. On state Q0, when we give an A, we go to Q1 state. On Q1 state, when we give an A, we go to Q1 state. And on Q1 state, when you give a B, we remain in Q1 state. So this is the list of transitions which we have for this NFSM. If we were to write the same using a transition table, then we will be writing like this. Q0 on seeing an A goes to Q1 state. Here there is no transition defined for B, and Q1 state, which is the final state, when we see an A goes to Q1 state, and when we see a B, we go to Q1 state. This NDFSM, which we have designed for the language that starts with letter A over a set of alphabets sigma is equal to A, B, has to be converted to its equivalent DFSM MD equal to QD sigma delta D Q0 FD. Given a NDFSM that looks like this for a language that starts with letter A over a set of alphabets sigma equal to A, B, then we know that this has to be converted into its equivalent DFSM. Now, the first step in the construction of DFSM is to identify the start state of the DFSM. We know that the start state of the NDFSM is denoted as Q0. So this is the start state of the DFSM, and start state of NDFSM is equal to the start state of the DFSM. We have seen this in the steps explained in the previous video. Therefore, if Q0 is the start state of the NDFSM, then Q0 will also be the start state of the DFSM. This is our first step. The second step in the conversion of NDFSM to DFSM is to identify the alphabets of the DFSM. Now we know that sigma is the alphabet set of NDFSM. Therefore, sigma will also be the alphabet set of DFSM. So sigma of NDFSM will be the sigma of DFSM. This is our second step. The third step in the construction is to identify the states QD of the DFSM. Now we know that the states Qn of the NDFSM is equal to, Qn is equal to two states, Q0 and Q1, and QD, that is the states of the DFSM, is equal to 2 to the power n, where n is the number of states in NDFSM. So here we have got two states, n is equal to 2. Therefore, QD will have 2 to the power 2 states, that is equal to 4 states. And these 4 states are the subsets of the states of Qn. Therefore, we will have one empty set. QD will have one empty set. We can write it as 5. Then it is one element set, that is Q0. Then it is a Q1. And then we have Q0 and Q1. Therefore, we have 4 states in the DFSM. The next step in the subset construction method is to identify the transitions delta D of the DFSM. Now, before we find the transitions delta D of the DFSM, I will first list out the transitions delta N of the NFSM. So, we have delta N is, we have two inputs A and B, and there are two states in the NFSM. Q0 is the start state and Q1, which is the final state. Now Q0 on receiving A goes to Q1 state, and Q0 on receiving B, there is no transition which is defined, I'll put a dash. Q1 on receiving A goes to Q1 state, and Q1 on receiving B also goes to Q1 state. Now we have seen that this delta D transition, in order to construct delta D transitions, we will consider all the states QD of the DFSM. So we have QD states as 5, then we have single element set Q0 and Q1, and then we have Q0, Q1. So transition delta D is given as following: two inputs A, B. The first transition for delta D on state Q0, or first we'll start with the 5 state, empty set, there is no transition defined, so we can write 5 and 5. Next is the start state Q0. We know that the transitions for the start state Q0 are the same as that of the NFSM's transition. Therefore, Q0 on receiving a A goes to Q1 state, and Q0 on receiving a B, there is no transition which is defined. There is a note here. Every dead configuration in NFSM is a dead or a trap state of DFSM. So we know that this, instead of writing a dash, we can also write it as 5. So instead of writing a dead configuration, I will write it as QT. Okay. Next is the state Q1. There is state Q0, then state Q1. Now this state Q1, on seeing a goes to Q1 state. On seeing a B, we go to Q1 state. Next state Q0, Q1. Now we know that since we are having a combination of two states, delta D transition of Q0, Q1, that is combination of two states on input symbol A, is equal to delta N transition of Q0 on A union delta N transition of Q1 and A. So we have union of these two transitions, that is Q1 itself. And then for input B, it is these two, union of these two transitions, again that is Q1. Since Q1 is the final state of NFSM, wherever Q1 is present as an element, all those states are final states of the DFSM. We shall make use of these transitions in order to draw the transition diagram. We have Q0 as our start state and Q1 and Q0, Q1 as the final states according to the previous slide. Therefore, Q0 on seeing A, it goes to the state Q1, and on seeing a B goes to state Q trap. Q1 on seeing A remains in Q1, and on seeing a B also remains in Q1. Then we have a state Q0, Q1. Q0, Q1 on seeing A goes to Q1 state, and on seeing a B also goes to Q1 state. But we can see that this state cannot be reached from the start state. Therefore, we can eliminate it from the final transition diagram. There is no way you can reach here, right? Therefore, you can eliminate from this diagram. And then we have a transition here, Q trap. Once the system goes in Q trap, irrespective, it stays in the Q trap state itself. So this particular state can be eliminated, and we have only two transitions here. Okay. With this, we have Q1 as our final state. The final transition diagram for a language that starts with letter A over a set of alphabets sigma is equal to A comma B can be given as the start state Q0. On seeing A going to Q1 state, on seeing a B goes to Q trap state. Q1 state, it's a self loop for both A and B input, and Q1 state is our final state. Then the Q trap state, which remains once the system goes into Q trap, it remains in Q trap.